PC USB projects is all about home building and upgrading existing electronics from components that you have at hand. It is fun, not only because it is thrilling and exciting to test a new drone, vehicle or other device that you've just built or modified, but also because it can do things that are impossible with consumer electronics. Own programming unlocks numerous possibilities of alternate uses. For example, an internet radio with a Wi-Fi and a wired Ethernet connection can also double as a wireless router or a sniffer. A weather station can also be a security and logger device. Home-built electronics may also turn a remote-operated toy like a model John Deere tractor into a true robot. LED lighting controller can also monitor Wi-Fi networks or even operate as a wireless router or network extender. Artificial intelligence is the key of building successful home robots. Though it is relatively easy to add a new sensor, it takes much more to write an AI firmware with information processing abilities. A simple remote-operated vehicle or a drone with a camera can only relay camera's video stream to a human operator, but a robot can also process information itself and act upon it to avoid crashing into an obstacle or even stop or land itself safely when the batteries are exhausted. PC USB Project's website has recently celebrated its 10 years anniversary. How it has all begun. 10 years ago, I wanted to add computer automation to my home, but the old PCs with a number of easy-to-program printer and serial ports were gone. But I had learned that I could use a popular Velman K8055 electronics kit as a controlled interface. USB connection to a PC was the only thing needed. The kit came with a prepper-groomed PIC 16C745 microcontroller. After assembling it and adding relays, my home automation began to work. A year later, I also got myself a newer K8055 and board that was based on a newer 3.3-volt PIC 18F24J50 microcontroller. But in its pre-installed firmware, many advanced PIC 18F24J50, many of the advanced features were unsupported, so wrote a new firmware and built my own PIC 18 programmer to program it. A number of more sophisticated programmers, including the one for PIC 32MX programming, followed. You can get them from PC USB Project's website. In the following years, I coupled PIC 18 and PIC 32 with our FM69CW radio communication modules to create communication nodes that form the platform to build a weather stations 1 and 2 with remote measurements nodes. The weather station base module later also doubled a communication module for 2 remote-operated robots with PIC 32 control-based control module that communicates through our FM69CW radio module. I built a Microsoft Windows application to control the robots through the weather station using a joystick. However, PIC 32NX microcontroller family was followed by a much more capable PIC 32MZ family, which also raised my interest. But PIC 32MZ microcontrollers were much more difficult to use for home builders because they only came in chips with 0.5 more smaller pin spacing, which were difficult for hand soldering. Development board with PIC 32MZ 2048 ECH144 was therefore reasonable. But I still wanted to try building a development board myself, so I bought myself a relatively cheap PIC 32MZ 2048 ECH100 plug-in module for microchip development boards, and I built my own development board, which I named PIC 32MZ 2048 ECH100 Basic Circuit. In the next years, ESP8266 modules came into play. Espressif Motif, which later renamed to Espressif Systems, at first offered various ESP8266 modules as Wi-Fi modems, with no information on programming available. But as they gained popularity, they quickly joined Arduino Club, and they offered a plug-in functionality as well as program library support. Native ESP8266 native integrated development framework was also available for programmers that needed more functionality, but not limited to Arduino integrated development environment. Though I first intended to use ESP8266 module to provide modem Wi-Fi functionality to my PIC 18 and PIC 32 projects, ESP8266 Arduino programming support just became available at the time. Therefore, I rather used MCP2200 USB to serial bridge to connect ESP8266 module to my PC and program it. But I also learned that MCP2200 chip was in fact a microchip prepper-grammed PIC 18F14K50 microcontroller, which enabled me to also test my own USB to serial bridge firmware designs. However, the original, though read-protected microchip firmware was still better. Later on, I replaced MCP2200 with PIC 32MX250F128B, which was much easier to solder and also much faster as USB to serial bridge and achieved speeds up to 921,600 bauds. My own firmware also allowed for additional control functionality that enabled me to also operate ESP8266 enable, reset, CPIA 0 and CPIA 2 pins programmatically without using the usual micro switches. ESP32WROOM and ESP32WROVER modules were much faster, and I made a number of projects that include Internet radio with an Ethernet connection, Ethernet to Wi-Fi bridge, ESP32-based weather station 3, a toy helicopter drone attached camera, a radio-controlled John Deere tractor model with 2 inbuilt ESP32 microcontrollers, and finally an ESP32-based LED lighting controller that I use every day in my kitchen. I also experimented with adding proper Wi-Fi antennas to the modules instead of inbuilt PCB antennas to increase the communication reliability and range. Nowadays, Raspberry Pi Zero and Pico are slowly dragging home developers from ESP32 modules, but they can still be programmed through Arduino integrated development environment, which greatly simplifies their use for most home developers and even professionals. However, the bigger brother's Raspberry Pi 3 and especially Raspberry Pi 4 can also be used as desktop PCs. And this led me to design an interesting project. I used Raspberry Pi inbuilt serial port and its internal 3.3 volts power supply to program and run ESP32 modules with Arduino integrated development environment for Raspberry Pi, and this also allowed me to make a Raspberry Pi inbuilt circuit to remotely control and even lock my Raspberry Pi's power state through another Wi-Fi device. The latter includes another Raspberry Pi, a smartphone, etc. Go to PC USB Project's website to get instructions, blueprints, and source code for these and other of more than 100 projects. Thank you for watching. If you liked the video, please press like and subscribe buttons.